Hi everyone, welcome to my channel. I hope you are enjoying our machine learning series. So as part of this video, we are going to move ahead with our linear regression algorithm. So in last video, we discussed that we have a lot of points and we want to find out a line which best fits our points. Now, we had ended the video on this question that uh, how do we find out a best line? So now there could be many lines which we can think that can represent our model. This could be a line which will be going through our model, our data, and this could be another line which is also going through our data. How do we ensure that the line that we are selecting as our model is the best line which is fitting our data? So we had concluded that uh, the line which is going to best fit our data is going to have average, average error as minimum. So that's what we had defined in uh, our previous video. So that is called cost function. So we define a cost function uh, which is which calculates the error for every point from the line, and the purpose is to minimize that cost function. So we also call it loss function. So it is a measure of the error that we have in our model. So this these points are the actual values, and any value on the line is the predicted value, and we see that by on an average for every point how much error we are getting. There are different methods to get this error. So one famous method is residual sum of square. The formula is like this, that for every yi is the actual value, and uh, fxi is the predicted value, and we find out the difference between them, and then we scale it, and then we sum it for all the uh, values that all the records that we have in our data set, all the n records that we have in our data set. That is called sum of squares, residual sum of squares. So our purpose is to minimize this error. This is our error, and our purpose is to minimize this error. So that's the whole, that's if we minimize this error, then we can find out our best model. Now, so how do we minimize this error? So what we do, we we had decided, right? This is our hyperplane, W1 x1, W2 x2, and up to n variable, Wn xn. So this is what we have defined as our line, and what we do, we initialize these variables w1, w2 up to wn with some random value. No, I'm telling you the methodology to find out the most optimized value for these variables. We in starting we initialize these variables with a random value, and then by using a optimizing algorithm, we find out the most optimum value of these variables, uh, considering our data set. So now there are many algorithms which can do this. Most famous of them is gradient descent. Gradient descent. Gradient descent is only one of the optimal optimization technique. There is a stochastic gradient descent. It is also called SGD, and there are different methods, for optimizing uh, uh, optimizing a function based on a data set. So uh, gradient descent is most famous one for machine learning uh, things, and stochastic gradient descent and batch gradient descent. There are a lot of variations of it. So we will discuss gradient descent, stochastic gradient descent, batch gradient descent as a separate video. As of now, you can just assume that for simplicity of the things, that you know to find out the best line to represent our model, we initialize the value of our weights in our formula with a random value, and then we use the optimization algorithm to get the best value for our model. That's how we get our best linear regression model. I hope this is clear. So now, let us do an example of our linear regression. I'm again giving you a toy example, which is a bit more complex than the previous example that we had considered for our class. And we'll slowly increase the complexity of our example. We'll take some real, more complex data set, and it will be a progressive learning for you. So as part of this part two of linear regression, let us take the wine quality data set. It is a very famous data set. You can, uh, see there are a lot of data sets actually at this website. There are a lot of data sets for learning. Iris data set is what we used earlier, and there are a car evaluation data set, breast cancer data set, heart disease data set, wine quality data set. There are a lot of data sets that are available on this site. So I have just picked up wine quality data set, and specifically for red wines I have picked up. And let us see what exactly is this. First I'm loading pandas library. I had mentioned earlier about the pandas library. Pandas library is a library built on top of NumPy. It is very useful to visualize, not exactly visualize, it is very useful to do any kind of data analysis. So if you want to run any SQL queries, or if you want to do select some columns, put some condition, filter some data, so all this kind of analytics if you want to do, Pandas is a very good library. You can do some kind of plotting also using Pandas. Pandas internally use matplotlib for that, but using matplotlib directly is preferred. Pandas is more useful for filtering data, creating more columns for analysis and all that. Okay, let us download the data, wine quality data. Cool. Let us see in our current directory if we have it. I have a lot of stuff in my current directory. Okay, this is the data that we downloaded. Now let me create one more folder named data folder, and let me move my data into that folder. Okay, in data folder we have this wine quality data set. Cool. Now let us load this wine quality data set. I can just say pd dot pd is our short form for pandas. Pd dot read csv file, and separator is semicolon. Then I can print my data use function. So you can see that there are these columns: fixed XDT, volatility, citric acid, residual sugar, chloride, and all this information is given. Quality is the variable that we are interested in predicting. Now let us see some general stats about our data set, that what is the mean value, what is standard deviation, what is the minimum value, what is 25th percentile of data, and all this stuff, what is max, what is count. So all that stuff you can see. So I will discuss in our analysis video that why we need these kind of stats, but I'm just depicting you here that what a ML guy does, what a data scientist does when he is trying to understand a data. So these are all steps of understanding data. So once we have loaded the data, we normally plot the data using matplotlib. So we can do analysis between two variables. So we will see that how alcohol and quality column are related with each other. In a wine, how amount of alcohol content in wine is related to the quality of wine. Cool. So you can see here our data is right tilted, right side tilted. So we can see here that as the amount of alcohol quantity in wine increases, the quality of wine also increases. So there is a positive relationship between quantity and quality of wine. So then we'll see the relationship between two more variables like volatility, acidity in in wine, and quality of wine. So they have a negative relationship. As the volatile acidity in wine increases, the quality goes down. So similarly, we can do, find out relationship between other columns also. So here we don't see any strong relationship. Here also we are not seeing any strong relationship. So there can be situations that there are hundreds of columns in your data set, right? And so if you have lot of columns in your data set, it may not be possible to create a scatter plot for every column with your output variable, or it will be a very time consuming process. So in that situation, you can use this function, correlation function. It will give you uh, all the relationship in a grid kind of form like this. So it will tell you that how quality is related to fixed acidity, how quality is a variable that we are interested in. I hope everybody is clear on that. Quality is related to volatile acidity, and how quality is related to citric acid, and how it is related to all our features. So there is even better way of visualizing it using Seaborn library. Seaborn library is a library which is created on top of Matplotlib, and it makes making plots even far more easier. So I'll just show it here that how can we create heat map for our use case. So this is how you can create a heat map. So darker is the color, more uh, strong relationship is. So you can see here. Okay, sorry. Lighter is the color, more strong relationship is. Darker is the color, lesser strong relationship is. So you can see here that alcohol has strongest relationship with quality, and volatile acidity is least related to quality. So this can we visually also you can make it very quickly. So now let's put fit our linear regression model on this data. So similarly, we'll split our data set into train and split uh, sections. So I'm just selecting all the columns in our data set except the last column. This is what this command on my screen shows up. Now quality is our output variable, so I'm just selecting it. Now I am splitting my data set. Now I am initializing linear regression variable. Yes. Now I'm fitting my model. Cool, my model is fit. Now let us do some predictions on our model. Cool, we have done predictions. Okay, we have got some accuracy of 35, accuracy score of 35, which is not that great. Okay, so I wanted to introduce you to cross-validation score also. So based on what sample was selected as part of this train test split, our model accuracy can change. So it is better to select multiple samples and train our model multiple times and select the best model, or take an average of average of the score of the models, multiple models. So that's exactly what cross validation does for us. It will We can tell it that how many times I want to select different random samples, and how many times I want to do cross validation. So here, we are giving it the model that we want to train our input data, and I'm telling that I want to do this exercise 5 times. So it will calculate score for those 5 models and it will show it to me here. So based on whatever input sample we used, our accuracy is coming differently. So sometimes it is very low and sometimes it is a bit higher, but still considerably low. So here we trained our first model. We plotted our data, and this is a normal process a data scientist or a machine learning guy goes through. I hope we are clear that how to use linear regression. In our next video, we will see that how we can improve the results of our linear regression model by using regularization, by using scaling of our features, why it is important to scale our features, how to do missing value treatment, all those things we'll look into. So as part of this video, I hope you are now more comfortable with linear regression, and you should try this code yourself. It is very easy, and I hope this video is very useful for everyone. Thank you for watching this video.